looking at these two wells, what do I know now?
Patient A has diphtheria.
Patient A has diphtheria because it turned yellow, which means that the antibody or the enzyme attached to diphtheria, which attached to another antibody, and since those antibodies are so specific, I know without a doubt that person has diphtheria.
Okay.
Is that okay? What about I look in this well, patient B? It's clear, right? So I know, what do I know?
No, they do not have
They don't have diphtheria, but do I know they have tuberculosis?
No.
No, it doesn't tell you what they do have, it tells you what they don't. Well, it does tell you what they do have. But if it says that they don't have what you tested for, it's all you know. In order to confirm it, I would have to do one on tuberculosis. That's why you want to make sure you know what you're looking for before you do it, because otherwise you'd have to do an ELISA test for like every single disease, and that would take forever and cost a lot of money. Okay, so you hope that your doctor gets it right the first time. Is that okay?
Mm-hmm.
Any questions on that before I move on to the
Can you
next
say that
part?
one phrase again? The enzyme linked, like you
Oh,
just
the
worded it really
enzyme
nicely. Like,
link-
you
the-
know diphtheria is diphtheria because.
Okay, let me see if I can remember what I said. You know, when you look into this one, you see it's yellow, right?
Right.
Now, because it's yellow, you know the enzyme reacted with the substrate, right?
Yeah.
Now, the enzyme is attached to a diphtheria-specific antibody. So because it turned yellow, you know that the diphtheria-specific antibody with the enzyme attached to diphtheria. And for diphtheria to be in there, you know it attached to the first diphtheria-specific antibody. So I'm just going backwards
Right.
on the
What
steps.
turned yellow? Like the whole well?
The substrate, yeah, the whole well. The substrate is the liquid inside.
Oh, okay.
And so you pour that
So the
liquid in,
liquid
if there's an
turns yellow?
enzyme, it reacts with the substrate, changes the whole well yellow.
So the
How do you
water is-
actually see this? Like
You look-
antibodies going in?
You don't, well, you like pipette them in.
Okay.
So you have the patient sample and you like put it in. And then once there's a color change, you can observe that. But you can't look in and be like, oh, I see antibodies
That'd be
attaching.
really cool though.
Yeah.
Yeah.
They're way too small.
The substrate is like a liquid.
Yeah, it's a liquid.
Are antibodies, are they bacteria?
Are they bacteria?
I don't know.
They are produced by your immune system.
Okay.
So you have plenty of antibodies. Who has had chicken pox in here? So you guys all have chicken pox specific antibodies going through your blood right now. And that's why you won't get it again, because the next time you're exposed to it, those antibodies will stick and kill it before it can take over.
So they're not like good bacteria. They're just
No,
like
they
some
go
they're their
against
own
bacteria.
thing.
Yeah, they're very good for us.
This is kind of
We're getting close. Can I do an ELISA test on bacteria?
Yes.
Mhm.
Yeah, those are my two examples, right?
Mhm.
What did he use as an example in the case study? What disease did he use?
H1N1
Which is a
virus.
virus. So can I do it on a bacteria, an ELISA test?
Yes.
Can I do it on a virus?
Yes.
What do I need to do an ELISA test?
The antibody of it.
Specific antibodies.
Mhm.
Now, if you're in a hospital and I think this person has necrotizing fasciitis, and I don't have any antibodies for that, can I do an ELISA test on it? No. As long as you have a specific antibody, you're good. I like to say, if you had an antibody for dirt, you can do an ELISA test on dirt. Mentions one of your diseases is pertussis. Can you do an ELISA test on pertussis?
Mhm.
Can you do it on diphtheria?
Mhm.
Can you do it on anthrax?
Mhm.
Influenza, MERS, what was your last one?
Chickenpox.
Chickenpox, right? So you can do it on any of those as long as you have the specific antibody.